Right, okay, so it's a question about, in general abstraction. Lots of people, when they answered this, the big problem was they gave general answers. At A-level, general answers are, in general, bad. If you've got a context, you need to answer the question in context. So, the question said, car simulator uses abstraction, and this is for testing a range of cars on racetracks, so it's racing. Identify 2 ways in which the simulator can use abstraction. So we're looking, you've got, first off, it's what does abstraction mean? Now that's a GCSE word. Abstraction is about focusing on the detail that matters, ignoring the things that don't. You could actually write a million different things for this answer. So you think about, they're simulating the car, what are they ignoring? What are they not going to care about? So, trackside details probably don't matter. Okay, we're going to be concentrating on the track, the car running on the track, so maybe the physics of the wheels on the track. I don't care whether I can render a tree with a squirrel in it that's like having a fight with another squirrel over a horse chestnut. Do I? I could do that, but actually I could ignore that. So if it's anything sensible, it could have been like reflections of the sun on the paint. It could have even been what the car looks like, didn't matter. Because all you're simulating may be an in-car view, and you just want to be able to see the track. You know, like when you're playing some games and you can go on low-down track view, like bumper view or whatever. You don't even render the car. You're not interested, we're simulating. So the context was the important bit. So people who didn't get any marks on that said things that were either generic or actually were a bit bonkers. Okay? All about context for these questions. The next bit, some people got this, some people sort of saw the word input and then didn't read any further. Okay, so if you read as far as identify 3 inputs and then went, excellent, 3 inputs to a racing simulator. Steering, gearbox, clutch, accelerator. No, that's not what it asked, because if you carry on reading, it said, required to configure the initial conditions. So setting it up. So again, you think in racing simulator, what might we need to set up? Well, the obvious ones that jump to me, what car are you in? So picking your car, picking your track, picking weather conditions maybe. Is it rainy? Is it dry? Track conditions. Is there a lot of rubber on the track? Is there dirt on the track? Are there winds? So you've got to think about that. The driver maybe. So it might be, because you're doing a simulation session, you want to log what driver's running in the car. But it had to be set up things. It's no good, it didn't ask for, while the simulation is running, what are we going to do? If it just said, for controlling the simulation, all those people that said steering input, gears, brakes, yeah, that'd have been fine. But that's not what it asked. Okay? Any queries about that? I will bang on about context all the time, because context is king at A-level. There's not many questions where they say, oh, do you know what this term means? You get the odd bit of that, but not much. Okay, the next thing. And remember, these are A-level questions. So this was actually quite interesting, but it had some elements that people just ignored. It said a programmer is going to design a procedure. So this isn't just an algorithm, it is a self-contained subroutine that will prompt the user and receive 2 values, A and B. The procedure will then compare them, and then it will write a suitable message to a file on disk. If you're asked to write to a file, you start putting print, then you've just thrown marks away. Print is to the screen, isn't it? if you're asked to do a file, then you're going to open a file and write to that file. It's the same code effectively as print. But there you go. Right, and another thing that we need to get used to, if you're inputting data, we store it. So there is a standard way of writing that. So if they're called A and B, so I have to use A and B. So put my drawing tool on. Thin pen. Going to go thin pen. Thin pen. Thin pen. Very thin pen. Right, so I'm going to say, right, A equals, so I say like, I'm going to store something in A. What am I going to store in A? The input. So if you've ever got to do user direct input, you're going to do it like this in pseudocode. So, and a suitable message so the user knows, enter a number. I'm just going to put a num. And I'll do the same for B. So if you're ever asked to get user input, you're going to say, enter another number. You're going to do that. You're showing the example that you understand assignment operations. Okay? Right, and then he's going to compare the two numbers. So we're going to do an if. Right, and we have got, with numbers, they can either be bigger or smaller than each other or the same. The order you tackle this is up to you. So I would generally, I'm going to say, right, if A is bigger than B, then I'm going to write out that A is bigger. Okay? But it actually had, it said write a suitable message. So are they the same? A is less than B, B is less than... So I'm going to write out, in this case, B is less than A. But where am I going to write it? I'm going to write it to a file. I'm not going to put print. In order to write to a file, you have to have a file open. So I need to make sure that the first thing I did was to say something like F equals... Whoops. Oh, I can't do undo on this. It's a stupid thing. Oh, the rubber's terrible. Let me zoom that in a bit. Right, so I'm going to say F equals, and I want to open a file. So it's pseudocode. As long as I'm making it clear that I'm messing about with a file, so I'm just going to say open, open, and then I'm going to have a name. So output.text or something I'm going to call it. And I'm going to just put some indicator that I'm either reading or writing. So for this one, what am I going to do? Read or write this file? I'm going to write it. So you can, it's pseudocode. So as long as the intention is clear and it's in a code-like format, so I'm just going to say write. So anyone reading that is going to go, all right, you're opening that text file in write mode. That's fine. So to output to a file, you're just going to say F dot, and we use the dot notation just like we do when we're doing C#, and we're just going to say write. And we're going to write out the statement, which was, let me just scroll up a little bit so I can see that. B, in this case, is less than A. That's all I'm going to do. Files are easy. It's the same as printing, it's just that you're directing the print to a specific location. Right, okay, so that handles one condition. So if A is not greater than B, we've still got two chances of it being two things, haven't we? It's either going to be the same or A is going to be less than. So we can say else. Now if you want to put elif, that's fine, just like you do in Python, but else if, and then put the next test. So I'm going to say, well, hang on a minute then. Is B greater than A? I can't guarantee that it is. And if that is true, we were supposed to output A is less than B. So I'm going to say, right, okay then, write out. So to that file F, A is less than B. Now, I think the mark scheme wasn't too picky as long as the message you wrote in was tied in with the logic that you put. Right, so if A is greater than B, or B is greater than A, that handles those two cases. Do I need to do another test? It's not wrong to do another test, logically, but it's wasteful. It can only be bigger, greater, or the same. So the option that we would then put is just say, right, okay, else, write out that final statement that the values are the same. So this will get you all but one mark. Does anyone know how we get the final mark? Close the file. Excellent. Yeah, whenever you do a file opening, I didn't mean that. I meant to scroll that. At the end, so I'm just going to put Ed. At the end, I just need to make sure that I close that file. Now, does anyone know the technical reason why we have to do this? And to close the file, you just go f.close. That's it. So if you ever get a file question, open a file, close file. That's it. That's all you got. You'll get a mark just for doing that, generally. Anyone know technically why we close a file? Go on, go for it. Right, when we write to a file, we actually don't directly write to a file, we write to an area in memory, a buffer. When we say close, what the OS will do is it will flush that buffer to the file that was associated with it. So actually, if you get a program crash in the middle of writing to a file, you'll find that there's nothing in the file, or the file hasn't updated or whatever. Because the flush didn't happen. You didn't get that far. If you forget to close a file and then just kill a program, then you won't have anything in it. You learn the hard way when you do loads of web programming to close files, because it can leave you in. And the other thing that the problem is, if you don't close a file, that memory is still allocated to that file. And unless the operating system is clever and then goes, oh, hang on a minute, we've got some dead buffers here, let's get rid of them, you'll eventually run out of memory. Because if you keep running that program again, and it opens a buffer, and then you kill it, opens a buffer, and then you kill it, eventually you'll do a Skyrim. And you'll crash after 8 hours of playing. Just what Skyrim did. It had memory leaks. Memory leaks are the killer of many a program. Murder, this is one of the hardest things about doing C++ and C. Because you have to release all the memory you've allocated yourself. It's not magic like C#. Yeah. Okay, anyone got any queries about that? So, file questions, this was quite nice because they actually gave you a chance of getting some marks here, even if you couldn't do the file. There'll always be easy marks. Even if you look at an algorithm and you think, I have no idea. If it's got a starting bit where it's saying, like, get the stuff off the user, then do it, you can do that. Not hard. Right, okay, moving on. I don't think anyone got this right. I'm not surprised, because it is not GCSE. Right, does anyone know what bival means? No. So that's the critical bit. This is a parameter. Okay, when we're writing modular programs, we pass data to our modules for them to work using parameters. We can pass parameters by value, which is a copy, or by reference, which is a memory location. So, just because we've got this doesn't mean it affects anything else. Name is a copy when it's sent. So the name given here is just what add message refers to that piece of data it's got. We'll look at this in detail when we look at how the stack is used to pass parameters. Okay, so don't worry if you don't don't really understand this yet. Yeah, so that's just a copy. A copy is actually put on the stack. So it uses that and it goes in-text equals a low plus in-text. So at this point, and it becomes what we call a local variable, in-text will say, hello, Sam. And then we get to this line and we say, right, destroy that. Destroy it. Destroy it. Its usefulness is over. I only wanted it to exist during the running of this procedure. So when we get back down to this line, name hasn't changed. Now, some people were talking about global variables and things like that, but it's not that. Okay? But you were going off the information you had. Like I said, the people who had a go at these questions, even if they got them completely wrong, it shows that you went, right, let's try and reason this through. As you get more knowledge and more technical content down, when you get in a situation where you think, oh, I can't remember this, but I can reason this through, you'll be able to reason things through better. And you'll get closer to a good guess. Okay? Critical. Guessing is critical. I have won bottles of champagne by guessing in quizzes and stuff. When I've been head-to-heads and things like that with people. And people went, how did you know that? And he went, that's a total guess. I just gave it an educated guess. Using what I know. I don't know anything about that, but I'll tell him. Right, okay. The next bit, modular approach, is how we're going to tackle everything that we do when we program. Modular just means using decomposition to break things up. So we write snippets of code and we store them as functions, procedures. The advantages of it, the reason we do it, we're trying to speed things up, development. We're trying to minimize errors. So instead of having to debug an entire program, if you've got a fault, you should be able to track it down to a module. You then debug the module. If you want to change how a module works, you only have to work on a module. You don't have to work on the whole program. If you make sure that these are pure modules that do one function, then they're never going to be very complicated. So again, simplify, makes it easier to write accurate code that works, that's easier to test. Everything that we get asked about why we do certain things as programmers, always ties and comes back to the same thing. Producing, well, I was going to say error-free programs, but that's tosh. There's no such thing. Minimizing errors. Because if you minimize errors, you increase development speed. If you increase development speed, you drop the costs, you allow yourself to do more. Okay? And modular is like a cornerstone of this. We used to have to write programs and we didn't have subroutines. That was a nightmare, writing code that had to work. So you had one big loop controlling everything, and then everything else that had to happen, where you would normally put a subroutine, you had loops inside loops inside loops. So you had to think in a really hideous way about how you broke a program down. So you had to break a program down into a true hierarchy. Horrible. Horrible. But then we started writing procedures and things, and that makes everything better. Okay? And then we build on that by using objects, which takes it to another level. Okay, so it's all about, but the key thing was not just to say what modular was. They don't care about that. It was explain the advantages. They expect you to know what modular means. They haven't said, what is modular? They've gone, right, okay, you know a load of stuff about computer science. You tell me why we're doing all that stuff. Why and how are the two important questions that you should always be asking yourself. So whenever you're doing notes, and we'll kick off with this Cornell notes thing next term, when we're doing notes on topics, one of the aspects you have to do is to take facts and turn them into questions. So you should be looking at why and how in everything that you know. Okay. Right, and then the final one. Pretty good, but some people obviously cocked up numbers and things. Most people had to go at this, and I don't think anybody got 0. Quite a few people got 4. This is just a case of trying to follow the logic through. Okay? It had something called XOR, which might have caught a few people out, because we never did that at GCSE. Okay. The truth table for XOR looks like this. Let me just draw it. So if you've got two inputs, so it works like an OR and an AND. So you've got two inputs which could have these possible values. And the A XOR B, one of my year 13s, he decided that that was pronounced Zor. Which I thought sounded like some sort of like evil overlord. So I then started saying Zor. And the mighty Zor. If you look on the review for Class B on the A-level computer science, I'm in there. I was chuckling for a long time afterwards. Right. The way that right, let's have a quick recap. If I did AND, what would be the truth table? What would be the first one? Naught and naught. Naught. Naught and one? No. One and naught? One and one? One. Oh no, on my own. Or is naught. Okay. Right, exclusive OR is weird. It's I always describe it because when I'm coding and I use it in assembly language, I'm using it as a toggle. I use it, yeah, you can use your logic, but it's a toggle. So we use it and we've got to look at something called masking when we get a little bit later on. And we can use it to flip bits. And the way it works is, if they're the same, you get a 0. So when you've got two noughts, you get a naught. When you get two ones, you get a naught. But when they're different, you get a 1. So if you've got a true and a false, then the output of exclusive OR will be true. If you've got a false and a false, it's going to be false. If you've got a true and a true, it's going to be false. Okay? So you might have needed that, but not to get all the answers. So let's just run through this. So we're running with A is 42 and B is 41. So we look at the first if. It says if A is greater than B. No, that's not true, but we've got an OR here, haven't we? So let's look at the other bit. Is B greater than or equal to C? No, that's not true either. Okay? So if that's not true, then we're skipping all of this down to here. So we should get D is 14. Yeah?
No.
No? What have I done wrong?
A is bigger than B.
Ah, A is bigger than B. So this is true, isn't it? The rest of it, and the really key point when you're doing these, if you are doing an OR and the first thing is true, you don't even have to look at the second one. No point is there. You've got a true already. Right. It's very important. That's how easy it is to make a mistake. Which is why some people put the odd wrong number down. And you think, well, you got the others right, but you just cock that one up. Just like I did there. Right. So we're into this line for this first one. Is C less than A? No, it isn't. They'll always try and catch you out with something being the same. Right, so we're looking at XOR. Is C less than B? No. So that actually is true. Isn't it?
No.
Why isn't it?
Both are incorrect, so it's not true.
Yeah. Okay, so that's not true. So we had two falses, and with exclusive OR, if we've got two the same, that's all you've got to remember, two the same is false. So we actually can do the else. So you should have got 16 for that first one. Right, run it again, but can you see what looks deceptively a simple question can actually really do your head in? Right, so the next one, we've got A is 42. So is A greater than B in this case? So we're back inside here. We don't need to look at the other one. So we're back in doing this again. Right, so is C less than A? That's true. Right, so if this next one's true, then we're going to be doing this one. Right, so is C less than B? So that's two trues, again, which gives us a false. So it's going to be 16 again. There is nothing to stop you, ladies and gents, annotating your way through this, putting little markers next to it so you know where you're looking. Right, the next one then. A is 42 this time. So is A greater than B? So in this case it is, again, but so now we're in here again. So we've got to check this XOR. So we've got, is C less than A? Yes. Is C less than B? No. We've got a difference. We've got a true and a false, which means we're going to output true, which means we should have got 15. And then the final one, we've got A is 42, B, where's B? Oh, give one potential value of B. Right, so this is what you would call the high order question, because they're switching it around a little bit and making you think. So we output 14, so we ended up down here, and they said a value for B. So we want both of these to be not true, don't we? To get down to here, this has got to be overall false, which means that's got to be false and that's got to be false. So whatever value we pick, right, so we've got A is 42. So we want B to be bigger than 42 or equal to 42, potentially. Yeah, so I'm going to write here, I'm going to say 42 plus, I don't know what value yet. Right, looking at the second one, B has got to be greater than or equal to C. What was C? 44. So what would be a suitable value that's going to make that false? Can't be 42, can it? So, 44? So if B was 44, would that work? What value are we going for? 43. Let's just check. So we put 43, and there's nothing to stop you doing this either. 42. 43. What was that? Right, so we've got A, so 42 is greater than 43. No. 43 is greater than or equal to 44. That's false. Yeah? So we got two falses. The only way we could get to that. So it had to be 43. Deceptive. You might have been tempted when you flick through the paper to start with that one. The first three were moderately easy. The last one, you've got to double check. I think it was the last one that a lot of people screwed up. You've got to double check yourself. And the only way really is to start writing the number you want to check next to it so you can see it. You did have a lot of space at the bottom, so you could have been doing your working out, potentially. Tracing logic is probably one of the hardest trace. If you're doing a complicated algorithm that's showing how merge sort works or quick sort works, and you're tracing an algorithm through, that actually is easier than doing something like this where they're trying to catch you out, and they are trying to catch you out. Okay? Right, that is the end of that.